Welcome to EDU World Space.
Alright guys, we're doing problem 114 of chapter 9 in Chemistry Essential Science. So sulfur tetrafluoride reacts slowly with oxygen to form sulfur tetrafluoride monoxide, according to the following equation. The oxygen and the four fluorine atoms in OSF4 are bonded to a central S atom. Balance the equation. We've done that over here. Now, write a Lewis structure of OSF4 in which the formal charges of all atoms are 0. Again, we've done that here. Now, use average bond enthalpies to estimate the enthalpy of the reaction. Is it endothermic or exothermic? So we're going to do that right now. That's a 2. We're going to use Hess's law. Delta H of reaction is equal to delta H of products minus delta H of reactants. That's times 4. Therefore, SF bonds, 327. Plus OS, 523. Minus 102, so 495, plus 2 times 4 times 327. And the answer to that's going to be so our delta H is going to equal 551 kilojoules per mole. And you can see that since our delta H is positive, that means this reaction is endothermic. So they want us to determine So they want us Indeed, they want to determine the electron domain geometry and write 2 possible molecular geometries for the molecule based on this electron domain geometry. So this electron domain geometry is trigonal bipyramidal because you have 4 electron domains, 4 single bonds and 1 double bond. A double bond still counts as 1 electron domain. Now, what are the 2 molecular geometries? Since we have electron domain geometry of a trigonal bipyramidal electron domain geometry, what are the 2 molecular geometries we're going to have? So I'm just going to move this over here. In fact, we don't need this anymore, so I can just delete that. So we can have 2 kinds of molecules. We can have molecular geometry. We can have this one. This is going to be trigonal bipyramidal electron domain geometry. And we can also have another kind of electron domain geometry, which is called square pyramidal. So since not all of the bonds are equivalent in this structure, it's possible we may have distortion from an ideal trigonal bipyramidal structure. So it's actually going to look more like this. So this is going to be a pyramid with a square base. So these are going to have, so for E, they want us to know how many fluorines are going to be axial and how many are going to be equatorial. So E and A. E for equatorial and A for axial. For this one, 3 are going to be equatorial. We have 3 in this plane, triangular plane right here. And 1 is going to be axial. 1 is going to be below our sulfur. And now for square pyramidal, we have 1, 2, 3, 4 that are equatorial. They're all in this plane, and 0 that are axial. And that's how we solve this kind of problem. In fact, let me just write down the names of these different geometries. Just